Alright, this is on exponential functions, and this is the standard form of an exponential function. F of x equals c times a to the x. A is greater than 0, a can't be 1, and c is greater than 0. Okay? So some examples. F of x equals 2 to the x. Base 2, and then there's the input into the exponential function up in the exponent. G of x equals 3 times 4 to the x. Now remember, this x input's only affecting the 4, and then it's 3 times that. So, for example, if I put x equals to 3, then x would be 3, and it would be g of 3 would be 3 times 4 to the third power. And you'd have to figure 4 to the third power out first, 64, and then multiply that times 3. So the outside one right there. So it goes up and it only goes on the 4, it doesn't go on any other number out front, that c value. C is also referred to as the initial value, and it's the y-intercept. So the c value, the value out front of this, is called the y-intercept. That's because if you put 0 into the function, if I put 0 in for x into the general term, a to the 0 is 1, and then 1 times c is c. So you end up getting that number right out front. So we'll say that f of 0 is c, and that's the y-intercept. So in our case here, my c value is a 1 right out front of there, so it crosses at 0, 1. But here, the y-intercept is a 3. So they usually have that as a starting value or initial value, because a lot of times in exponential curves we're in this graph here, and this this quadrant, and the starting value starts with 0, and then 1, 2, 3, like 4 days, etc. Alright, so let's look at an example here. F of x equals 2 to the x. What does that graph actually look like? Well, anytime you're graphing a new graph, you want to pick positive and negative numbers. So we'll start with negative 2. Let's go negative 1, 0, 1, and 2. And so if I put negative 2 in there, I get f of negative 2, 2 to the minus 2. But remember, 2 to the negative 2 just means 1 over 2 squared. You move this to the denominator and then square it out, which is 1/4. So that's 1/4. That means f of minus 1, 2 to the minus 1, should be 1/2. Okay? So if you did negative 3, you get 1/8. Alright, then you put 0 in there. 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. So now we can just start plotting those points. So we go to the graph, and we put those points in. Negative 2, 1, 2. Put a fourth in, really low. Negative 1, put a half in, right? 0, 1, 1, 2, and 2, 4. So you end up getting a curve that looks like this. Let's look at it on a better graph. There are my points. Negative 2, a fourth. Negative 1, a half. 0, 1, 1, 2, 2, 4, and that's the curve. You'll notice that as it goes to the left, it gets closer and closer to the line y equals 0, but you remember, by putting numbers into an exponent, you can't make it equal to 0. So you'll get closer and closer to 0, and that's what happens here. It gets closer and closer to 0, but never equal to 0. So there's actually a y equals 0 horizontal asymptote here. Then it shoots up dramatically fast. Look at the table over here. As you put in, say, 4, 5, 6, 7, 8, 10, look at that, 1024 at 10. Here, it's 1024. Okay? Let's notice a few things about the graph. The domain. What is the domain of this function? Well, it goes to the left forever, and it actually goes to the right forever, right? So the domain is all real numbers. Notice that it is 1 to 1, so that when I go across this way, I'm hitting it once, 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 right? It's 1 to 1, meaning it is a function that passes the vertical line test, but it also passes the horizontal line test. And for it to be, since it is 1 to 1, then an inverse does exist, and that's going to be a logarithm, and that's what we'll talk about coming up. We already talked about where the horizontal asymptote is, right? The horizontal asymptote is at y equals 0, and the y-intercept, if just in this form right here, the y-intercept is actually at 0, 1. And so if you don't have a c, it's always at 0, 1. But if there is a c, then it's at 0, c. Now I'd like you to try one. Here's f of x equals 3 to the x. Go ahead and create a t-table and pick some values for, x, maybe like -2, -1, 0, 1, 2, and see if you can graph it. Plug those in, plot the points, and graph it. Pause it, otherwise I'll finish it up. Okay, -2, put -2 in there. That's f of -2. That becomes 3 to the -2, which is 1 over 3 squared, which happens to be 1/9, right? Put -1, that's 1 over 3 to the first, so that's 1/3. Put 0 in, that's 0, 1. Put 1 in, right? 3 to the first power is 3. 3 to the second power is 9. So here is our points. -2, 1/9 right there. -1, 1/3 right there. Just a little bit further up, right? And then 0, 1 shoots up. Then as soon as it gets to 1, it goes to 3. And look at that, 2, 9, it goes really fast. So it's along here, right next to there, and it shoots up really fast. And continues that way, and continues that way. Okay? Now what would be the only difference, like if I put, say, a 2 out in front of here? Well, notice all these things would be 2/9, 2/3, 2, 6, 18. It would double all the outputs, right? Okay, and that's similar to transformations. And that's what we're talking about here next. Some of my questions are, what would these things look like? What would minus and then 2 to the x look like? What would 2 to the -x look like? Well, remember, 2 to the x looks like this. Okay, if you put a negative out front, that would flip it over, right? Because it takes the opposite of all these guys and flip it over. So the minus would look like this. Alright, what about this one over here? We have 2 to the minus x, so we'll do 2 to the x looks like this again. But then now you're taking the opposite of all the x values, right? So this was here, but now you're going to take the opposite of it, so now it's over here. So it actually would swing this way and go through, reflect over the y-axis, reflect over the x, reflect over the y. So all the same things you know about transformations hold true. Let's look at an example showing you that. Notice this, f of x equals 2 to the x minus 1 minus 2. Well, if you remember correctly, the x minus 1 part right in there moves things to the right 1 unit because it's affecting the x directly. And then this minus 2 part at the end right there moves things down because it affects the y, it affects the output. So we started with the graph 2 to the x, that's the graph right there. And then we subtracted 1 from the x, which moved it right. So here's a point, I chose this point, it moved it right and down, or down and right, but right and down, it kind of moved it right and then down. That's really what happened, the correct direction. So right and then down, 2 units. So this one, from here to there, right 1 unit, down 2 units. So the same kind of thing works with all the other transformations. Let's try one. What do you suppose would happen if I had f of x equals 2 or -2 times 3 to the x plus 5 minus 1. So I'm trying to incorporate everything. Okay. So first of all, the base is 3. Right? That's the base of this exponential. So it's the one we did earlier, where 3 the first, 3 the second, etc. Okay. Now things have been shifted. So it starts up here. The number comes in here and it's added 5. So we go left 5 units. Then the -2 multiplies all those outputs of here. So left 5 and then the negative portion flips over the x-axis, and the 2 doubles it all, and then doubles the output. So it doubles all the y values, and then finally, after doubling it, takes 1 off, so moves it down. Okay? Maybe we can look at that at the graph. So this is a regular 3 to the x that's been to the left, flipped over, doubled the output, and moved down 1. With the regular graph here, g, let's say, if you put in, say, 1 into that function, right? G of 1, you'll get 3 to the first, or 3. So there should be a 1, 3, a point of 1, 3 on this one. And we're going to see how that moves. Okay, let's look at the graph. Here's my point 1, 3. If I move to the left 5, let's do that. There we go. We moved it to the left. 1, 2, 3, 4, 5. Let's double it and then flip it over. So that's the doubling and flipping over. There's the flip over, and all the points have doubled now. And it moved over. So now let's go and up to it and finally move everything down 1. Because the horizontal asymptote is still at y equals 0, if I subtract 1, now the horizontal asymptote should be at y equals negative 1. Okay? So everything will work the same with all the other transformations as before.